Hello, and well, once again, a very good evening, morning, afternoon, evening, because right now I'm making the video, and take it as you would like it. And hoping you all are doing well, fine. Also hoping you all are keeping in touch with your studies, and also that you did visit, you did see, you did go through the previous video, and also if not my video, you can go through any video on, or any you can go through any source that does give you some information on ocean currents, because this is one very important thing which you should know and which you should keep in mind. Now, in the previous class I had told you all about gyres. You can see over here, in every ocean, or in every half an ocean. Over here, this is the North Atlantic Ocean. Over here you get a gyre. In the South Atlantic you get a gyre over here. In the South Pacific you get a gyre over here. In the North Pacific you get a gyre over here. So there are gyres in all the oceans. And if you just look closely in the oceans, you will find that the ocean currents follow a specific pattern. The warm currents, they move up, and the warm currents, the red ones show the warm currents. The warm currents, they move up, they branch, and then again they come down, and then they become the cold current. Over here also in the southern hemisphere also it is same. The warm currents, they come down towards the south from the equator, and then again they get up, or they again move up towards the equator as a cold current. So it is the same current which is flowing actually. So you find a circular movement. This is the gyres, or this is what is called a gyre. I had given you all a task in the previous video lecture to find out the names of the different gyres which are there. So a few names over here, you can see I have written the names for you all, so that you can understand. This is the Columbus gyre over here, named after Christopher Columbus, the famous navigator and explorer. So this gyre in the North Atlantic Ocean, this is the Columbus gyre. This gyre over here in the South Atlantic Ocean, this is the Navigator gyre. This Navigator gyre is, who was this navigator actually? So there was this one king, King Henry, and he was called Henry the Navigator. And this King Henry, he was a king of Portugal actually, and it was this king who had sanctioned so many different, and he had opened a college which used to train people in sailing and navigation. I'm talking of the 1500s. So back then, a king who took so much interest in sailing, navigation, in understanding the oceans and exploring the oceans. So this gyre is named after him. This is the Navigator gyre. Over here we have the Hydral gyre. Hydral, he was another scientist, geographer. We have the Hydral gyre. Over here we have the Turtle gyre. This North Pacific Ocean is the Turtle gyre. The South Pacific Ocean is the Hydral gyre. And over here, the Indian Ocean, this part, there's no specific name given over here, because this part, the current, they keep on changing, they keep on moving, because of they keep on shifting actually, because of if you remember, while I was talking of monsoon, or while I taught you all about monsoon, this keeps on changing because of the shift in the intertropical convergence zone, that is the ITCZ. So these were the different gyres which you understood. What are gyres? I guess you understand. And these are the different oceanic currents. Now let us just go through these oceanic currents in details. Before I go through these oceanic currents in details, I was talking of the effects of ocean currents. And over here there is one place. This place is over here near Canada. This place, this island which you see over here. Let me just zoom in for you. This island which you see over here, this over here is Newfoundland. And Newfoundland is actually belonging to Canada. This Newfoundland, this is the meeting place of two currents, one warm current and one cold current. The Gulf Stream, in red you can see, this is the warm current which is coming, and it's the Labrador Current which is coming down, which is the cold current. So this warm current and the cold current, they meet in Newfoundland, and Newfoundland is one of the most foggiest area in the entire ocean, or not only in this ocean, in the entire world. This is one very, very foggy area, and this fog is created due to the meeting of hot current and cold current. So this fog which is created over here, this fog, not only the fog which is created, something other, some important other thing was also created, or it happens over here. What actually happens is that the cold current, the cold if you remember in the previous video lecture, I had told you about, or I had told you that the cold currents, they actually bring in a lot of nutrients. the cold currents are nutrient rich. Why are they nutrient rich? Because they are moving on the oceanic floor, and the oceanic floor is containing so many different kinds of nutrients, they are containing so many different kinds of minerals. So the oceanic floor is actually, suppose this is the oceanic floor, and the cold current is moving over the oceanic floor. As the cold current is moving over the oceanic floor, it is collecting a lot of nutrients, lot of minerals. And when the cold current comes up, when there is upwelling, when a current goes down and it sinks into the ocean, it is called a downwelling of a current. DOWNWELLING. So it is the downwelling of current when something, when the ocean current is going down, is sinking into the ocean, and when the ocean current is moving up, it is called upwelling. So over here, what happens is, in this area, Newfoundland, the cold current, the Labrador Current, there's an upwelling of the Labrador Current. So this Labrador Current is bringing a lot of, when it comes up, when there is upwelling of the Labrador Current, what actually happens? I guess you all have understood by now. It brings a lot of nutrients and minerals from underneath the sea, and it brings it on the surface of the ocean. And there's this warm current, so there is warmth, there is a lot of minerals, and this place is having a lot of plankton. Why? Because a lot of mineral, warmth is there, and it is a perfect condition because of the nutrients, the minerals. The water is now full of nutrients and minerals. The current, the temperature is warm also because of the warm current. This creates a perfect environment for the growth of sea grasses, that is called planktons, seaweeds. The plankton, seaweeds, all these things are found over here. And because of so much fauna, or because of so much plankton, so much grasses, sea grasses, which is found in these areas, this becomes a favorite spot for fishes. And if there is a lot of fish over here, this becomes an area which is very famous for fishing. So this Newfoundland area is a very famous fishing ground of the world, and this becomes possible due to the meeting of two currents, the Labrador Current and the Gulf Stream. These two currents, they meet, and it creates one of the world's best area for fishing, one of the world's best fishing grounds. So this is, but also this area is very foggy. So you see there are two important things which happens when cold current and warm currents meet. First thing, fog is created in the ocean, and second, it creates or it brings about lots of flora and fauna, lots of fishes, and it becomes a very important area for fishing and economic activities. So this was about the effects of currents. Now just let us move on to the different currents of the Atlantic Ocean. Over here, this is your book, I guess, and you can see your book. You'll get this image in your own book also. So over here you see the Atlantic Ocean. Looking at the Atlantic Ocean, one very peculiar feature of this Atlantic Ocean is that it is S in shape, and this is the North Atlantic, this is South Atlantic. Over here, somewhere over here passes the equator, and over here the counter equatorial current. What is the counter equatorial current? I'll be telling you. Just let us look at this. Over here, North equatorial current flows. So as the North equatorial current, it starts moving from this area, it moves up. South equatorial current, it also starts moving from this area, and it moves downward. Now, I guess you have now understood why the counter equatorial current is flowing. What is the meaning of countering? Countering means going in an opposite direction. So the South equatorial current is moving in this direction. It is coming from the side of Africa and moving to South America. North equatorial current also moving from the side of Africa, going to South America, this side. What happens is that the currents are, as you already know now, currents are nothing but large masses of water. So large mass of water moving from this African side, going to this side, it wants to go up. Now what happens? It goes up, but some part of that water, on hitting the shores or on hitting the coast of South America, it returns. So it returns, it moves in the direction opposite to what the equatorial current is coming from. Try to understand, as the water is moving from this area, it is moving up. This is the north, as the North equatorial current. Again, water is moving down as the South equatorial current. As these currents are moving out, some part of the water also hits the, this is called the shoulder of Brazil. You can see this part looks like a shoulder of a person. So this is called the shoulder of Brazil. So as this north equatorial and the south equatorial current, they're moving up also, but some part of the water on hitting these areas, they return back, and this forms the counter equatorial current. It is called, in short, it is called the CEC, north equatorial current, the NEC, south equatorial, the SEC. Let's just look at the different points which are given. So these are two west flowing currents to the north and south of the equator, which flow from the western coast of Africa towards Brazil. So I guess you see it now, moving towards the west from Africa towards Brazil. They are north equatorial currents and the south equatorial currents, which originate due to the pushing action of trade winds and get their energy mainly from the trade winds that blow from the northeast and southeast in the northern hemisphere and the southern hemisphere respectively. So the trade winds actually they move in this direction, and in the southern hemisphere they're moving from the northeast to the southwest, and in the northern hemisphere they're moving from the southeast to the northwest. So this is the direction. In the southern hemisphere it is northeast to southwest. In the northern hemisphere it is from southeast to northwest. So this is the direction, and they give direction to these two currents, the north equatorial current and the south equatorial current. Why are these winds called the trade winds? Because previously, today we have motor propelled boats or boats and ships which run by motor, or there are ships which run due to nuclear power. But previously ships used to, or boats used to move by sails. Sail as in you have seen sailboats. There is a long cloth or a long canvas type of thing, and that sail moves due to the wind, and the sails, the boat moves because the wind is blowing on the sail and it is pushing the sail as well as the boat. So previously these trade winds actually helped traders move from one place to another, so as to take their trades and so as to take their goods from one place to another. So these things actually, or these winds helped the traders. That is why the name stuck. It is the name is called trade winds. So these trade winds also give rise to these two currents. Now these currents move westward along the equator due to the deflection created by the rotation of the earth, the Coriolis force. I guess this is amply clear to you all now. Now the protruding landmass of northeast Brazil, this they are talking of this landmass. This landmass, this is the shoulder of Brazil. You should keep this in mind. This is a very important thing and a very new thing actually for you all. So this is called the shoulder of Brazil. So this protruding landmass or the shoulder of Brazil splits. So it divides this current into two. One moves towards the north, one moves towards the south. One part crosses the equator and moves along north along the Guyana coast. This is the Guyana coast over here, and this is known as the Seine current. Over here it becomes the Seine current. As the north equatorial current, it keeps on moving, this becomes the Seine current, but then it is the same current. As it moves from different areas, the names are changed. Over here it becomes the Gulf Stream, then it becomes the North Atlantic Drift, and other moves south. The southward moving current, the south current, is called the Brazilian current. Now what happens between 10 degree north and 10 degree and 20 degree north latitudes? The slow moving equatorial north equatorial current moves westwards. So you can see, as this north equatorial current, it moves up. What happens now? It keeps on moving and then it turns towards this direction. So this is actually this westward drift. They are talking of this area actually. So a part of this current flows towards north of West Indies and becomes the Antilles current. So they are talking of this area actually. So this becomes the Antilles current over here. It is not given in the book, in the diagram, not that important. And the rest enters the Caribbean Sea where it joins the Seine current. So they are actually basically they are talking of this part. You do not need to keep in mind this is north equatorial current. Over here it becomes the Seine current, and then it becomes the Antille current, and then they together form the Gulf Stream again. So you just keep in mind it's the north equatorial current becoming the Gulf Stream, and it then drifts off as the North Atlantic Drift. The next part, the counter equatorial current. So what happens is that the current which flows between the north equatorial current and the south equatorial current, what I was explaining, they are telling the same thing. The the north equatorial current and the south equatorial current, they are moving from this western coast of Africa towards the eastern coast of South America, and a lot of water, you can see it is given over here, a lot of water piles up sorry, a lot of water piles up due to the convergence of these two currents. And what happens is that as the currents, they are moving from this area, they are moving here, they keep on piling up, and then this area becomes excess in water. This becomes high pressure area, this becomes low pressure area, and some water, you all know fluids, they flow from high pressure areas to low pressure areas. So again the water flows from this part to this part. This gives rise to the counter equatorial current. I guess till this part everything was clear. In the next video lecture we'll be covering the Gulf Stream and the North Atlantic Drift. Till then, please take care, stay safe, and stay amply happy. Thank you.